Today we will be doing vectors. You have already been introduced to vectors in physics, and we will be doing the same chapter in maths, and we will be following the sheet which I have already given to all of you. If you have a look at type 1 of the sheet, type 1 talks about collinear and coplanar vectors. Now, first of all, what is the meaning of collinear vectors? Collinear literally means having the same direction, or you can say parallel. So, collinear vectors means they are having the same direction, or in other words, they are parallel. So, whenever you have two vectors A and B and they are collinear to each other, so you will find that A is a scalar multiple of B. So you can write vector A is equal to scalar into vector B. Now if two vectors are coplanar, it means they lie on the same plane. So let us say you have A, B and a third vector C which is in the same plane as A and B. So if you draw a line parallel to B and if you draw a line parallel to A, then automatically this will become multiple of B and this will become multiple of A. So vector C will be equal to x into vector A plus y into vector B. Remember that x and y both should be non-zero. So for collinear vectors, the equation is vector A equal to k into vector B, and for coplanar vectors the condition is C is equal to x into A plus y into B, where x and y both are non-zero scalars. Let's have a look at question number 1 of type 1. It says that it says that 4i plus alpha j plus k is equal to p into beta I plus 2j plus k. So if you compare both sides, then you will get these three equations: 4 equal to p beta, alpha equal to 2p, p equal to 1. So basically alpha will be 2 and beta will be 4. So the answer of question number 1, alpha is equal to 2, beta is equal to 4. Now let's have a look at question number 2. Now in question number 2, it's telling that there are three vectors and you're supposed to prove that they are coplanar. So x into I minus 2j plus 3k plus y into I minus 3j plus 5k is equal to minus 2i plus 3j minus 4k. Now if you compare on both sides, x plus y equal to minus 2, minus 2x minus 3y equal to 3. So 3x plus 5y equal to minus 4. After comparing ijk coefficients, you are getting these equations. Now what we will do is that we will solve these two simultaneously. So you can multiply this equation with 2 and add both of them. So you will get minus y equal to minus 1, which means y is 1. Once you get the value of y, put it in any equation. So you will get x equal to minus 3. Once you have got x and y, put both of them here and just check whether it's matching. Yes, it is. Minus 9 plus 5 equal to minus 4, it is matching. That means that this equation is valid with two non-zero values of x and y, which means that the three vectors are coplanar. So this is the way to do the sums of type 1. Next we come to type 2. Now type 2 is with regard to dot product of vectors. If you have two vectors A and B, this is the dot product of them, modulus of A into modulus of B into cos theta. So basically one vector A is like this, one vector B is like this. Theta is the angle between them. So A dot B is modulus of A into modulus of B into cos theta. Now, thanks to physics, you are already familiar with orthogonal triad of vectors. You will be able to easily verify that I dot I, J dot J, K dot K all are equal to 1. Secondly, I dot J, J dot K and K dot I all will be equal to 0. Now, if you take any vector and do dot with itself, the answer will be modulus of A whole square. So A dot A will be equal to modulus of A whole square. Now suppose you drop a perpendicular from the head of A onto B. So it's pretty clear that this length will be equal to modulus of A into cos theta. Now the thing is that modulus of A into cos theta is this, and this is also called projection of A on B. So modulus A cos theta is also known as projection of A on B. You can write it in another way. Cos theta is A dot B by modulus of A into modulus of B. So finally it's coming A dot B by mod B. So this is a very, very important formula, the projection of A on B. Now sometimes you will be asked to find the projection vector of A on B. Now if you are asked to find the projection vector of A on B, then it will be A dot B by mod B whole thing multiplied with B by mod B. So projection vector of A on B is A dot B by mod B into B by mod B. So what you are basically doing is you are multiplying the projection with unit vector in the direction of B. So these are the concepts that are required in type 2. Now have a look at question number 7. It says that A plus B plus C is 0. Now if you take modulus on both sides, then modulus of A plus B plus C will be 0. Now you square this. So A plus B plus C dot A plus B plus C. So A dot A plus B dot B plus C dot C plus 2 into A dot B plus B dot C plus C dot A. So 3 plus 2 into A dot B plus B dot C plus C dot A. So we are getting A dot B plus B dot C plus C dot A is equal to minus 3 by 2. So in this way we can do question number 7. Now one very good thing about dot product is that it enables us to find the angle between two vectors. So we can say the angle between the two vectors cos theta is equal to A dot B by mod A into mod B. We can use this formula to find the angle between two vectors. Now have a look at question number 9. It says show that I plus J plus K is equally inclined to the axis. So you can say cos theta 1 is I plus J plus K dot I by root 3 into 1. So the answer is coming 1 by root 3. Cos theta 2 is coming I plus J plus K dot J by root 3, so 1 by root 3. And cos theta 3 is coming I plus J plus K dot K by root 3, so that is 1. Since all the three cosines are the same, cos theta 1, cos theta 2, cos theta 3, all three are same. That means theta 1, theta 2, theta 3 are same. That means I plus J plus K is equally inclined to the axis. So these are the various examples of type 2. Now we come to type 3. Now type 3 is based on geometrical properties. For example, suppose you have a triangle ABC and the three sides of the triangle are represented by the vectors A, B and C. So A plus B plus C is clearly equal to 0. So we will get A plus B equal to minus C. Now what you can do is you can take modulus on both sides and square. So A square plus B square plus 2A dot B is C square. Now you can write minus of 2A dot B is A square plus B square minus C square. Now 2A dot B is minus 2AB into cos 180 minus C. So finally we will get cos C is A square plus b square minus c square by 2ab. So this is actually question number 11 part 2. So we are simply using the geometrical properties of vectors. Like, have a look at question number 13. It says that prove that if the diagonals of a parallelogram are equal in length, then it is a rectangle. So suppose the adjoining sides of the parallelogram are A and B. So this is O, this is A, this is B, this is C. In this parallelogram, the diagonal OC, you can see by very simple triangle law, it is equal to vector A plus vector B, and the diagonal AB, it will be equal to vector B minus vector A. Now the thing is that if the two diagonals are equal, then we are getting vector A plus modulus of A plus B equal to modulus of B minus A. Now you square both sides. So A plus B dot A plus B is equal to B minus A dot B minus A. So you will get A square plus B square plus 2 into A dot B is equal to A square plus B square minus 2 into A dot B. So you will get A dot B equal to 0. That means angle AOB is 90. Now if angle AOB is 90, it means that it is a rectangle, because in that case all the four angles will become equal to 90 degree. So these are the examples of type 3. Now we come to type 4. Type 4 talks about cross product. First of all, what is cross product? Suppose there are two vectors A and B. So if you want to calculate A cross B, then that is equal to modulus of A into modulus of B into sine theta into eta. Eta is unit vector perpendicular to the plane of A and B. You can easily get the direction of eta by using right hand rule. You take your right hand and curl the fingers from A to B, and your thumb will point towards eta. That is how you find eta. In fact, specifically to find eta, the method is, if you take modulus on both sides, then modulus A cross B is modulus of A into modulus of B into sine theta. So now if you divide these two equations, then you will get eta is A cross B by modulus of A cross B. So if you want to find eta, this is the formula. You can easily verify that I cross I, J cross J and K cross K will all be equal to 0. Secondly, if you have a circle with IJK placed in anticlockwise order, then I cross J is equal to K, J cross K equal to I, K cross I equal to J. So I cross J equal to K, J cross K equal to I, K cross I is equal to J, right? So these are the three formulas to relate I and j. If you ever have a reverse order of cross product, like suppose if you have j cross I, then the answer will simply be minus k, right? So these are all the different cross products between I, j, k. Now one very significant thing about cross product is that it has lot of geometrical application. For example, suppose you have a parallelogram in which the adjoining sides are vector A and vector B. Suppose this angle is theta. Now if you drop a perpendicular, then this will become modulus A, this height will be modulus A sine theta, and this base will be modulus B. So the area will become modulus A into modulus B into sine theta. So this is the formula to find the area of the parallelogram. So we can say that the area of the parallelogram is nothing but modulus of A cross B. Another thing, suppose you have a parallelogram excuse me, suppose you have a triangle in which one side is vector A, another side is vector B. So if you draw the altitude, you can easily see that the length of the altitude will be modulus A sine theta, and you can see that the base will be modulus B. So the area of the triangle will be half modulus A sine theta into modulus B. So it will be half modulus A cross B. So the area of the triangle is half modulus A cross B. Okay. Now suppose you have a parallelogram in which you know that the diagonals are modulus, vector A and vector B. Suppose you have a parallelogram in which the diagonals are vector A and vector B. So you have four triangles of equal area. So the area of any one triangle will be half into modulus of half A cross half B. And like I said, you have four such triangles. So that means the final answer will be half modulus A cross B. So these are three very important results. Area of a parallelogram with adjoining sides vector A and vector B is this. Area of a triangle with one pair of sides vector A and vector B is this, and area of a parallelogram whose diagonals are vector A and vector B is this. Suppose if A and B are in orthogonal triad form, suppose vector A is A1i plus A2j plus A3k and vector B is B1i plus B2j plus B3k. In that case, the cross product is given by the determinant ijk determinant I, J, K, A1, A2, A3, B1, B2, B3. So this is the best way to calculate cross product of two vectors if they are given in the orthogonal triad form. Let's have a look at sum number 20. It says that if A plus B plus C is 0, if A plus B plus C is 0, in that case, what we can do is we can do both sides cross with A. So A cross A plus A cross B plus A cross C is 0. So A cross B is equal to C cross A. Similarly, if you do both sides B cross, then B cross A plus B cross B plus B cross C is 0. So you will get B cross C is equal to A cross B. Now if you take these two together, you will get A cross B equal to B cross C equal to C cross A. Let's have a look at sum number 21. There is a triangle ABC. So vector A, vector B and vector C represent the three sides, and the question says you have to prove this. Incidentally, there is no need to do this because we have already done this in the previous sum number 20. You can see that A plus B plus C is 0, and similar to number 20, if you proceed, you will get this result. Now there is a second part of sum number 21 which says hence deduce the sine formula. Now A cross B is equal to B cross C. So modulus of A into modulus of B into sine 180 minus C is modulus of B into modulus of C into sine 180 minus A. So you will get modulus A into sine C is equal to modulus of B into sine A. So you will get mod A by sine A is equal to this will be modulus of C is equal to mod C by sine C, right? So we will get modulus of A by sine A equal to modulus of C by sine C. In this way, we are able to get the sine formula. Now we move on to type 5. Type 5 basically talks about scalar triple product. Type 5 is about the scalar triple product. What is scalar triple product? If you have three vectors A, B and C, then A dot B cross C is called scalar triple product. Now, there is a convention, scalar triple product is written like this, enclosed in square bracket, vector A, vector B, vector C. This is the way to write scalar triple product. It can be easily shown that scalar triple product follows cyclicity. That means A dot B cross C will be equal to B dot C cross A will be equal to C dot A cross B. All the three will be the same. If A, B, C are in orthogonal triad form, suppose ABC are in orthogonal triad form like this. In that case, scalar triple product is given by determinant A1, A2, A3, B1, B2, B3, C1, C2, C3. So this is the value of scalar triple product using orthogonal triad form. Now you will notice one thing, that if A equal to B or B equal to C or C equal to A, then the scalar triple product will be 0. Scalar triple product will always be 0 if any two of the three vectors are equal to each other. Now scalar triple product has got a geometrical significance. Scalar triple product gives volume of parallelepiped formed by vector A, vector B and vector C. Scalar triple product of ABC gives the volume of the parallelepiped formed by vector A and vector B and vector C. Now if the scalar triple product is 0, that means vector A, vector B, vector C are coplanar. So this is the best way to confirm coplanarity of three vectors. If the scalar triple product comes 0, that means the three vectors ABC are coplanar. Let's have a look at question number 25. It says that prove that ABC are coplanar if and only if A plus B, B plus C and C plus A are coplanar. So you have to prove that A, B, C are coplanar if and only if A plus B, B plus C, C plus A are coplanar. So let's do one thing. Let's write the scalar triple product of these three vectors. Let's write the scalar triple product of A plus B, B plus C and C plus A. So obviously that will be equal to this. So inside the bracket you will get B cross C plus B cross A plus C cross C plus C cross A. As you can see, C cross C will be 0. Now you open the bracket. So A dot B cross C plus B dot C cross A. So you will get twice scalar triple product of ABC. So the scalar triple product of A plus B, B plus C and C plus A is twice the scalar triple product of ABC. This means that if this combination is coplanar, then definitely this combination will also be coplanar and vice versa. So that completes the proof of sum number 25. Now we come to type 6. Type 6 talks about vector triple product. Suppose you have three vectors A, B and C. The vector triple product is A dot C into B minus A dot B into C. This is the vector triple product. Have a look at question number 27. In question number 27, you are asked to simplify the vector triple product A cross A cross A cross B. Now, how do we simplify this? So, what we do is we say that you begin by first simplifying the innermost one. So, it's A dot B into A minus A dot A into B. Now, if you open the bracket, you will get minus A dot A into A cross B. Now, if you want to remove this minus, you just have to write A dot A into A cross B. So, this is the way to do vector triple product. So, this completes type 6 and it also brings us to an end of the session, vectors.